Hey guys, I have your notes here for section 9.3 day 1, and we're going to delve a little deeper into parabolas, which I know that you've dealt with before. And before we get started, I wrote down a few things that I think that you already know about parabolas. And I kind of went in order like, yeah, I'm pretty sure everybody's going to remember number 1. I think everybody's going to remember number 2. Some people are going to remember number 3, maybe number 4, So, number 1, I think most of you know that when you see the standard form of a quadratic equation, you know that the graph is going to be a parabola. I think you kind of know that. I think you know that in order to find the x-intercepts of a parabola, you set your equation equal to 0 and you solve. You solve either by factoring, greatest common factor, or unfoiling, or you can use the quadratic formula. You were taught, whether or not you know this or not, you were taught that if your leading coefficient is positive, your parabola opens up. If your leading coefficient is negative, your parabola opens down. The axis of symmetry is a line that goes through the middle of your parabola. So if your parabola looks like this, your axis of symmetry looks like this. We might be getting into stuff that you have kind of forgotten by now, but some of you are going to remember that in order to find the vertex of your parabola, that's this point right here on your parabola, you put negative b over 2a, you sub that in for x. And then you do the math, and whatever you get as your y value, that goes here. And thus you have a point, an ordered pair for your vertex. That's what you've been taught so far about a parabola. So we're going to go a little bit deeper, and I'm going to talk to you about a different form of a quadratic equation. Let's talk a little bit about up-down parabolas. Let's also talk a little bit about sideways parabolas. Interesting. And I want to introduce 2 new vocabulary words to you today. A focus and a directrix. The definition of a parabola. Now, I'm not huge on definitions. I don't have you memorize definitions, but this is kind of cool. The definition of parabola is the set of all points. By the way, there's an infinite number of points because there's arrows on a parabola. The set of all points that are the same distance from a fixed line, which is called the directrix, and a fixed point called the focus. So 2 new words, 2 new properties of a parabola. We've got a focus and a directrix. So the focus is always going to be inside your parabola. Like your parabola is always going to try to wrap around the focus. Your parabola is going to be focused on the focus. The directrix is a line. It's either horizontal or vertical depending on the position of your parabola. It's a line outside the parabola. And our parabola is going to be directed away from the directrix. See how it's opening away from the directrix? It kind of wraps around the focus. We say it's focused on the focus, and it's directed away from the directrix. Now, I want to show you something kind of cool. I've graphed a purple parabola. Everybody see the purple parabola? The blue are the x and the y axis. And the red line that you see is called the directrix. It's not the axis. This is the axis. This is the directrix. And the focus of the parabola is right here. It's this point right here. So what I've done is since the definition of a parabola is all points the same distance from a point as to the line. Same distance from the point as to the line. So, what I have done I have measured 2 segments. I measured the distance from A to B, and it calculates it over here. It says the distance from A to B is 1 centimeter. I've also calculated the distance from the vertex to my red line, my directrix. So from A to D, those letters might be too small. It's okay. This distance from the parabola to the line is 1 centimeter. Do you see how they're the same distance? From the parabola to the focus, from the parabola to the directrix, each is 1. Now here's what's cool. Anywhere I go on this parabola, anywhere I go, I'm going to grab this point anywhere I go. I think I'm going to go here. The distance back to the focus is 5.45. The quickest distance down to the directrix is just going to be a perpendicular line. This distance right here, 5.45. Anywhere on my parabola, coming back to the focus, coming back to the directrix, it's the same distance. Anywhere I go. (12.19, 12.19). Each green segment. You can go on the other side. 10.1, 10.1. That's what a parabola actually is. The set of all points equidistant to a focus and a directrix. Anyway, I hope you found that kind of cool. Stuff you never knew before about a parabola. Okay. Now, in the next few days of notes, you will see pictures of what shape of graph we're talking about. You're going to see pictures. You're going to see equations. And you're going to see all kinds of information down here. I'm going to highlight in pink every single time the information that you will be given on a test or quiz. You don't have to memorize it. So this right here, it's given to you. You don't have to memorize it. This right here, it's given to you. You don't have to memorize it. I'm not highlighting any of this. None of this is given to you on a test or quiz. But that's okay. Personally, I don't use it. I'm going to, it's there. It's in your notes in case you want it. But you've got this information on this set of notes, and then a couple days from now, we're going to do ellipses, different shape, different equation, different information. And then the next day, we're going to do hyperbolas, different shape, different equation, different information. There's no way you're going to be able to memorize all this information. How about you understand the concept, and then there's nothing to memorize. Nothing to memorize if you understand the concept. So, going back to what you're used to, you know that if your x is what's being squared, if x is what's being squared, your parabola is going to open up or down. However, if y is what's being squared, your parabola is either going to open right or left. And we've done some of that before in pre-cal. We've talked about sideways parabolas. And prior to today, you've learned that if A is positive, it opens up. If A is negative, it opens down. So I'm going to introduce like a new variable to you, and it's called P. P is the distance from the vertex to the focus. P is the distance and direction from the vertex to the focus. Now here's what I mean by that. Distance and direction. So from the vertex to the focus, this distance right here is P. P. All right? If P is positive, the focus is up. It's in the positive direction from the vertex. If P is negative, the focus is down in the negative direction, and thus my parabola would wrap down around it. So P is direction, positive or negative, and distance. Well, here's the cool thing. If this distance is P from the vertex to the focus, so is this distance, the vertex to the directrix. It just doesn't contain the direction like this does. P is the distance from the vertex to the focus. That you do need to memorize. Okay? And you're going to see P in the equation right here. P is the distance and direction from the vertex to the focus. It goes right here in my equation of a parabola. And then my vertex goes here and here. This is the x coordinate of my vertex and the y coordinate of my vertex. You've done things like this before. You've made equations of circles. You've seen stuff like this before. And then if your parabola opens sideways, now it's the y that's being squared. See how if you foiled that, you would have a y squared? If P is positive, it opens this way. If P is negative, it opens this way. And my center is this, comma, this. This goes with the x. So this is my x coordinate of my vertex. This is my y coordinate of my vertex. All right. So keep in mind, those pink equations stay with you the whole time. You don't need to memorize those. You just need to be able to use them over and over and over again. So what I'm going to do, it says find the standard form of the equation of the parabola. So you all are used to calling this standard form. Well, that was when you were in Algebra 1, you were kind of babies. So that was standard form. I'm going to call this polynomial form. This is our new standard form. It's like a more grown-up version of a quadratic equation. We're going to call this standard form. So here I go. Let's write an equation in standard form for these parabolas. Now, for every parabola that we do, for number 1, A, B, and C, our vertex is going to be at the origin. Now, remember how I said I don't memorize any of that stuff? None of it. So what I'm going to do, each time I need to make an equation, I'm just going to give myself a quick sketch of my parabola. I'm going to sketch it. Here I go. It told me the vertex is at the origin. Put your vertex at the origin. I'll try to color code it so you can follow me. Vertex at the origin. All right. The focus is at -2. I'm going to graph this. 0, -2. Focus. 1, 2. That's the focus. That's the vertex. Can you see how the parabola opens? Remember, the parabola opens. It kind of wraps around the focus. The parabola is focused on the focus. So the parabola is going to open like this. Right? My vertex is at 0, 0. What's P? P is the distance from the vertex to the focus, and it includes direction. So I think this distance is 2, and the focus is down 2, away from the vertex. So P is -2. Make your equation. Oh, also, one more thing. This is an up-down type of parabola. It's our x that's being squared. This is the formula. This is the equation that we use. My vertex goes here and here, which that's going to be 0. P goes there. And the 4, automatic. Put it in. So my equation, I'm going to go parentheses, x minus 0 equals 4 times -2, so that was P, parentheses, y minus 0. Clean it up a bit. This is silly. This is silly. Back up, back up, back up. Sorry, not squared, not squared. Whew. The x is the only one squared in a parabola. It's an up-down parabola. That one's squared, that one's not. My bad. There you go. And this is a different form than you're used to, but it's okay. It's our new standard form. Let's try another one. Vertex is at the origin. Give yourself a quick sketch. Put your vertex at the origin. Now, your directrix, remember that's the line. Your directrix is a line x equals -5. X equals -5. 1, 2, 3, 4, 5. It's a line. X equals -5. It's a vertical line. That's your directrix. Draw your parabola. Well, remember, here's your vertex. Your parabola has to open away from the directrix. Direct it away from the directrix. So I think my parabola has to open like this. Don't you think? Where's the focus? Well, it's the same distance away as the directrix. So if the directrix is 5 away this way, then my focus is 5 away this way. What's P? P is 5, and the focus is in the positive direction, right? Positive direction, negative direction. P is in the positive direction, so P is +5. My vertex is at 0, 0. When I go to make my equation, it's a sideways parabola, so we're going to make sure that we're copying this one. The y is what's being squared in a sideways parabola. Y minus 0, quantity squared, equals 4, that's automatic, times P, times x minus 0. This one is squared, this one is not. Now, clean it up a bit. This is silly, this is silly. Next. Quick sketch. Vertex still at the origin, because I'm still in problem number 1. Vertex is at 0, 0. This is worded weirdly. I really don't like the way it's worded. The axis of symmetry, what I meant by that was the axis of symmetry is the vertical axis. So the line passing through the center of the parabola is our y-axis. So it's going to open up like this. So I'm going to choose the up-down version of my equation. So I'm going to go x minus 0 squared equals 4 times, I don't know what p is. It doesn't tell me what p is. It's your job to find it. Figure out what that is. We have to have a value for p in order to finish our equation. The only variables we can leave in are x and y. Can't leave a p in my equation. So if that's still p, well, let's clean that up a bit. X squared equals 4 times p times y. I need to find p. Well, here's information that we have not used yet. I am given an x value and a y value that lie on this parabola, thus work in this equation. -4 and 1 has to work in my equation. Sub them in. So sub in -4 for x, sub in 1 for y. I got p equals 4. Now I can put it in my equation. Whoa. So I'm going to copy the equation that I just had, this one, except sub in x squared equals 4 times p, which is 4, times y. So x squared equals 16y. That's the equation of the parabola. Next one, now we're starting with an equation, and we're supposed to figure out, write down the point for the vertex, write down the point for the focus, write down the equation of the line for the directrix, and sketch its graph. So the first thing I'm going to do is try to manipulate my equation to get it to kind of look like one of these two. I'm going to get it to kind of look like one of these two. Well, in example number 2a, the one we're dealing with, the y is being squared. So I'm going to keep my y squared over here. Let's move everything else to the other side. Now, do you agree that the vertex is at the origin? Because this would be y minus 0, right? We don't write it like that, but that's what it would look like. So my vertex is at 0, 0. I have found one of the things that it's asking for. In fact, let's go ahead and graph it. Vertex 0, 0, right there. And since the y is being squared, we know that it opens, it's either left or right. It either opens to the left or to the right. How about we find the p value? This right here is supposed to be, remember in the formula what it looks like? There's a 4 there and a p there. So -10 is equal to 4p. This spot in the standard form of the equation is right here. Thus this has to equal -10 right now. Divide both sides by 4, p you can call it -5/2, you can call it -2.5, whatever. Let's go ahead and graph that. Let's graph our focus. Ready? Remember how I just said it opens either left or right? From your vertex, p is -2.5. One, 2.5. Plot it. I'll label that F for focus, V for vertex. Now, you can see how your parabola opens. Okay, what did it say to find? It said find the vertex. Check. Find the focus. Where is that point that I just drew? Give me that point that we just drew as an ordered pair. That would be -2.5, comma, 0. Focus, -2.5, comma, 0. I've got the focus, I've got the vertex. Now let's work on the directrix. Again, I'm going to go back to my sketch. If the focus was 2.5 away this way, that means the directrix has to be 2.5 away the other way. So the directrix is x equals 2.5. It's a vertical line. X equals 2.5. Oh, I guess I should have written those down there. Whatever. I've answered the question. I've got a sketch of the graph, and I've answered all the questions. Notice what I never used. I never used any of this stuff. Next one. Recognize what's being squared. So the x is what's being squared. I'm going to move this over to the other side. Here's what I get. Now we get to identify our vertex. You ready? Vertex. These are supposed to be minus. These are supposed to be minus. If these are minus, I'm just going to grab the number behind it. So this is a minus. So my vertex is at 1, comma. This is supposed to be a minus. Well, for this to be a minus, this 2 has to be negative. There's my vertex. Plot it. 1, comma, negative 2. I'll go V for vertex. All right, let's work on the focus. Well, to figure out where the focus is, I need to know what P is. So I'm looking at this spot right here again. This spot is where 4P belongs. So this is where 4P belongs. P is negative 3. Go back to your graph. P is negative 3. Hold on. X is being squared, up or down. P is negative. Down 3. P is direction and distance from the vertex. So P was negative, so I went down. P was 3, so I counted 3. That's the focus. Give me that ordered pair. What is this as an ordered pair? It is 1, comma 5. Here, I'll write it in the right spot this time. Positive 1, down 5. Okay, well, while I'm here, let's go ahead and open up our parabola. So the directrix has to be the other direction. The focus was here and it was 3 away. The directrix has to be 3 away. 1, 2, 3. It's going to be a horizontal line. 1, 2, 3. Horizontal line. And that's a horizontal. Y equals 1. Did I answer everything? Vertex, check. Focus, directrix, got it. Last one. Whew. Well, I have no idea. You know what I'm going to do? I'm going to draw a sketch. Vertex, negative 1, positive 2. Right there. Vertex. Focus. Negative 1, comma 0. All it gave me was the vertex and the focus. I didn't know which way it opened. I didn't know any of that. Now I do. This is the vertex. Your parabola has to pass through this, and it focuses on the focus. It's going to wrap around the focus, so it opens down. Opens down. That tells you which formula, which equation to use. It opens down. We're going to use the x squared equation. And we have our vertex. All we need is P. 1, 2. P from here to here is 2 down. Ready? Here's what my equation looks like. X minus negative 1 squared. 4 times P times Y minus 0. Whoa. I looked at the wrong one. My bad. Vertex. this one. Clean it up a bit. You can leave the parentheses. You don't multiply everything out. Just leave them. Leave this like it is. Leave this like it is. The only thing I would do is multiply these two together and do any, change it to addition or anything like that. All right. So, again, I encourage you, you don't have to memorize this. Do know that x squared is the up or down, y squared is the left or right. When p is positive, your parabola opens toward the positive direction. Good luck.